Hey there, HackerFrogs! This workshop is the third class for Intro to Python programming. During our last workshop, we learned a few programming concepts through Python, including the following. String formatting is a way for us to include variable values in strings by using C-style syntax. Strings in Python have a number of different functions and methods that can be useful for obtaining specific details about the strings. We can also output slices of strings through string indexing. Conditions are used in programs to determine a program's course of action. They rely on the evaluation of Boolean statements to determine if certain instructions are performed or not. New topics for this session are the following. Part 1. Programming loops. Part 2. Functions. Part 3. Classes and objects. Programming loops are tools that programmers use to run the same instructions multiple times. Here, the code repeats the instructions 4 times, and each time the value of I is printed. The first time, I is 0, then 1, 2, and 3. It stops before the number 4 because it started counting from 0. There are 2 major categories of loops in Python: for loops and while loops. We'll cover for loops first. For loops are instructions that repeat for each item in a set. The loop stops after the instructions have been performed on all items in the set. Any object that can be referenced by index can be used in a for loop, including strings. To write a for loop, begin with for, then a variable name that is only used inside the loop, typically the letter I, then in, then the name of the object to be iterated over, then a colon. On the next line, indent the line, then input the instructions to be run. Since a loop is a code block, all lines in the loop must be indented. All for loops iterate over the contents of an object, typically a list. In fact, the range function creates a list with a series of numbers depending on the arguments given to it. The other type of loop is a while loop, which, unlike the for loop, does not have an assumed end condition. Here, the loop keeps running until the count variable is no longer less than 3, and each iteration of the loop prints the value of the count, then increases the value of count by 1. We can see that while loops and if conditionals are closely related, since each time a while loop iterates, it checks if its running condition is still true, and ends if the statement is false. In the example, the loop runs over and over again while the statement supplied to it remains true. Once the count variable is incremented to 3, then count less than 3 returns false, and the loop ends. We begin a while loop with while, then the statement that must evaluate true for the loop to execute, then a colon. Then, on the next line, indent, then input the loop instructions. Typically, the last loop instruction progresses a variable towards a state where the loop condition will return false. What happens if a while loop is coded in such a way where the Boolean statement will never return false? The loop will never end naturally and creates what is called an infinite loop. Although there are cases where programmers want to create infinite loops in their programs, unintentional infinite loops effectively halt program execution, leading to system memory issues, crashes, or other problems. The break statement is an instruction we can insert into programming loops. When executed, the break instruction terminates execution of the current loop. This example also uses the while true style of loop, which is an infinite loop by default, and requires another means inserted within the loop to terminate the loop properly. For example, the break statement. The continue statement is an instruction that stops execution in the current loop and begins a new iteration of the loop. It differs from the break statement because it doesn't terminate the whole loop, just that one iteration of it. Just as we can use if conditionals within loops, we can use the else clause to execute instructions in the case that the if condition returns false. Let's practice using loops with Python at the following URL. In the first window, we see an example of a for loop. When run, the loop will iterate over each of the items in the list, printing out each item until all items have been printed. In the second window, info about the range function is provided. If one number is supplied as an argument to the range function, a list with all numbers up until but not including the number supplied in the argument is created, starting with the number 0. If 2 arguments are supplied to the range function, then the first number in the argument is the starting number in the list, and the second number in the argument is the number the list stops just before, not including that number in the list. If 3 numbers are included as arguments to the range function, the first and second numbers in the argument serve the same roles they did in the previous example, as the start and end numbers in the list, respectively, and the third number in the argument is the step number. That is, the number the list progresses by, with a step of 1 including all numbers, a step of 2 including every second number, etc. In the third window, an example of the while loop is presented. Note that the last instruction in the loop progresses the end condition of the loop. In the fourth window, the break and continue statements are presented. The first loop in the example is an infinite loop, but an if condition is included in the instructions, which executes the break command once the count variable reaches a certain value, and we see that each cycle of the loop progresses the if condition's trigger. In the second loop in this example, each number in the list will be printed to the console, but there is an if condition in the loop before the print instruction that will skip to the next iteration of the loop without printing the number, if that iteration's number divides evenly by 2. This is accomplished through the continue statement. In the fifth window, the else clause inside of loops is addressed. In the case of while loops, the else clause can be used as a final instruction that is executed when the loop completes. In this section's exercise, we're instructed to run a loop through a list of numbers with the following criteria. Print out the numbers in the order they are received. After printing out the number 237, the loop should terminate. Please pause the video now and attempt to solve the exercise yourself before proceeding. In the code block starting from line 13, we print the current number. Then on the next line, we create an if condition that checks if the current number is 237. And if it is, the break instruction is executed. After clicking the Run button, the exercise is solved. This is the end of Part 1. Programming functions are defined instructions that can be used multiple times in the same code. If a specific set of instructions needs to be run multiple times in the same code, it is more efficient to create a function out of those instructions rather than input the same instructions again. In fact, we've been making use of the most common Python function this whole time, the print function. Any arguments that the function requires to execute properly are provided inside the parentheses when calling the function. To create a function, start with def, then the name of the function, then a pair of parentheses, with any arguments required inside the parentheses, then a colon. Since a function is a code block, on the next line, indent, then input the function's instructions. If the instructions span multiple lines, each line must be indented. Any argument variables should be included in the instructions. Here, our example function is defined. Then the function is called, with the corresponding output shown thereafter. Return is an instruction that can be used in functions. When used, return stores the value specified, but doesn't print it out to the console. So the return portion of a function is useful for passing values to other parts of the program, but won't output to the console unless we use the print function with it. Let's practice using functions with Python at the following URL. In the web browser, we click on the blue Next Tutorial button at the bottom of the page. And in the first window, we see an example of a code block. And in the second window, we see a function definition block. At the end of the script, if we add an instruction to run the function, we see that the print instruction from the function is executed. In the third window, creation of functions using arguments is demonstrated. The arguments for functions can be either existing variables or arbitrary values. In the fourth window, use of the return statement is demonstrated. Remember that the return instruction normally doesn't output anything to the console, so to display the results of function calls, we should use the print function with the function call as the argument. In the fifth window, a summary of function calls is presented. Note that on line 18, the x variable is defined as the result of a function. This is quite typical in Python programs. In this lesson's exercise, we're instructed to do the following. 1. Modify the list benefits function so that it returns a list of strings. 2. Modify the build sentence function so that it returns the benefit argument, but concatenated with the string is a benefit of functions. Please pause the video and attempt to solve the exercise yourself before continuing. For the list benefits function, we can simply copy the strings from the exercise description, then paste them into the list. For the build sentence function, we return benefit plus the string is a benefit of functions. Click on the Run button, and the exercise is complete. This is the end of part 2. Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming. Python is an object-oriented programming language, and as such, all pieces of data in Python code are considered objects. In addition, all objects in Python are separated into different classes. We see that the 3 variables here are in the integer, float, and string classes, respectively. An object's class indicates which built-in functions, methods, and variables it has. Here, we've executed a function and method on the myString variable. Both the len function and upper method are unique to the string class. If we change the myString value to an integer, executing either the len function or upper method would result in an error message. To create a class, we begin with class, then the name of the class, then a colon. The first letter of the class name is capitalized. On the next line, indent, then def, then double underscore, init, a pair of parentheses, then inside the parentheses, self, then any other attributes the class requires, then a colon. One important feature of class creation is defining the double underscore init function, which specifies the attributes of the class. One attribute which all classes share is the self attribute, which is used to access other attributes and methods of the class in the code. Let's practice using classes and objects with Python at the following URL. Click on the Next Tutorial button to proceed. In the first window, an example class is defined. In the second window, we learn about how to create objects that belong to classes we've defined. As illustrated on line 7, we define a variable as the class name, but add an empty pair of parentheses to the end. In the third window, we see that once a variable has been defined as an object of a specific class, the object can then use the class's variables, functions, and methods, which is illustrated in the fourth window. In the fifth window, the concept of modifying object attributes is addressed. If we click on the Run button, we see that although myObjectX and myObjectY are objects in the same class, they are not clones of each other, since they can be modified individually after creation. In the sixth window, a demonstration on accessing object functions is presented. But we've already had experience with using object functions and methods, especially string objects. In the seventh window, we see the double underscore init function, which is used to assign values in a class when it is initiated. Here in the number holder class, we see that the double underscore init function is used to assign its self and number values. Further down in the code, we see an example of class object instantiation. The var object is an instance of the number holder class, and it's been created with the value of 7 in its number attribute. When using the number holder return number method, the object returns its number attribute value. We've arrived at the exercise for this section. We're tasked with creating two objects in the vehicle class called car1 and car2. Car1 should have the color set to red, the kind set to convertible, the name set to fur, and a value set to 60,000. Car2 should have the color set to blue, the kind set to van, the name set to jump, and the value set to 10,000. Please pause the video now and attempt to solve the exercise on your own before proceeding. Since the vehicle class doesn't have a double underscore init function, we can't set vehicle class attributes on instantiation. One solution to this exercise would be to create the vehicle class objects, then set their attributes one at a time in the following lines of code. Another way we could solve this exercise would be to modify the class to include the _init function. We write it out like this. Then define the vehicle class objects like this. Then we click the Run button to complete the exercise. This is the end of part 3. Before we finish, let's write a program which features many of the concepts we learned in this workshop. We can use the window in the Learnpython.org website to write the program. The program should have 2 lists, one with 4 colors, blue, red, green, and yellow. The other list will be a list of 5 fruits: apple, orange, grape, banana, and watermelon. The program should have a function which loops through a list, printing out each item. The function should be called twice, once for each list. We will go over a possible version of the program next, but you should try writing your own version now. The following code will fulfill the exercise requirements. If we paste the code into the Learnpython.org webpage, we see that the program prints out the list contents as expected. Let's review the programming concepts we learned in this workshop. Loops are tools that programmers use to run the same instructions multiple times. Loops can either execute a preset number of times before terminating, or iterate through all items in a list or string, in the case of for loops, or run continuously until a predetermined trigger state is achieved, in the case of while loops. Functions are defined blocks of code which can be executed multiple times in the same program. Executing a function is usually referred to as calling a function, or a function call. Python is an object-oriented programming language, and as such, all pieces of data in Python code are considered objects. All objects belong to a class, and an object's class indicates which built-in functions, methods, and variables it has. In the next HackerFrogs AfterSchool programming workshop, we'll conclude our Intro to Python with the Learnpython.org website. In the next workshop, we'll cover the following topics: dictionaries, as well as modules and packages. Looking for more study material on this workshop's topics? See this video's description for links to supplemental documents and exercises. Until next time, HackerFrogs!